Last time we said neural networks grow straight out of regression. But why would anyone build one in the first place? Forget that they exist for a moment. Let's start from a real business problem and see what forces you to invent one. Here's the problem. A camera sends you 5 million photos every single day. Each one is a pedestrian, a car, a motorbike, or a truck. Your job is simple to say out loud, look at each photo and tell me what's in it. And how is it done today? You've got a team of people sitting there, eyes on the screen, tagging photo after photo by hand. It half works, but it's slow, it's expensive, and it just cannot keep up with millions a day.
So what kind of problem is this really? Why is it so hard for a normal program?
Because this is a perception problem. It's a brain problem, not a programming problem. When you glance at a photo, you don't calculate anything. You just see it's a car instantly. That instant knowing is what we need to copy. Think of the end of The Matrix, where Neo suddenly just sees the whole world for what it is and reacts in a blink. That's perception. Your brain recognizes a friend's face across a street in a fraction of a second. No math involved. Now here's why ordinary programming fails. Normal code is rules. If x is greater than 5, do this. If x is less than 5, do that. But there's no rule you can write for, is this a purse? You just know it. Rules can't capture that. So the researchers did the obvious thing. If the brain solves perception so well, copy the brain. Loosely model how brain cells connect and fire. That copy, that brain-inspired machine is exactly what a neural network is. So a neural network isn't magic. It's an answer to one honest question. How do I get a machine to just see? Next, something surprising. How you could tackle this same photo problem without any neural network at all.